Hi everyone. This is for the week of May 11th. We're going to work on some more measurement. We'll be talking about milliliters and liters, which are again part of the metric system. We'll also talk about, so those you use for volume and capacity. We'll also talk about US customary units for measurement of capacity and volume, like cups and pints and quarts and gallons. We're going to do some problem solving, and we're also going to look at some clocks. So working on telling time, firming that all up. Here we are on Monday, May 11th. Here's a few things for you to think about and work through today. Have you ever seen one of these water bottles? So we're going to talk about milliliters and liters. This water bottle holds 1 liter of water. It takes 1,000 milliliters to fill to make a liter. I actually have one of those same ones, different color. I bet some of you have something like this around the house. So even up to this very first line down here, right there, that's 100 milliliters. So 1 milliliter is such a small drop of water. Sometimes you might remember in your house you might have like a little medicine dropper, like a little syringe that when you were younger or a younger sibling, that you would get a liquid form of medication of some sort, and your parents would measure it out in that little syringe. And those are milliliters. They're so small. So I just put a couple little droplets of liquid here. So when we're talking about volume and capacity, we're talking about how much liquid would be able to be held in a container. So this water bottle, same as that I have here, holds 1 liter. So up to this line is 1,000 milliliters or 1 liter. Again, this is metric, so it makes those really easy comparisons. Let's try some of it. So as we work through these units of capacity or volume, we're looking at these metric units. You might remember from last week that there were 1,000 millimeters equaled 1 meter. We also needed 1,000 grams to equal 1 kilogram. See how easy that is to convert? So for our capacity unit of liters and milliliters, notice that milliliters are abbreviated with a lowercase m and a capital L. Liters will be noted with a capital L, like right here. So we're going to use these containers to see how many milliliters we can find in there. So if you notice that right here, there's little tiny lines going up so that we can see what they are. Right here is 50 milliliters. That's really not very much. Do you remember the water bottle I showed you where it would get to be 100 milliliters? It's not a lot of liquid. So we could probably assume this is counting up by tens, but I should probably look too. If I say 10, 20, 30, 40, 50, that got me there. And you can kind of see that we're actually looking at this line in the front to see where that is going to be here. It almost is easier for me to count backwards from 100. So if that is 100 milliliters, that would be 90, and that would be 80. So this is 80 milliliters. Now on our second container over here, we have them, they're going up by hundreds, but do you notice the little marks in between? So it says 100, and then there's a little mark, and then it says 200. So think about on a number line, what is midway between, let's say 200 milliliters and 300 milliliters? You're right, that would be 250. So that line in between the hundreds is 50. So again, we're going to look at this front line here because you can see that the liquid is, that's where it is here, and then this line back here is like behind, showing you a little three-dimensional effect. So for this amount of liquid, we're midway between 300 and 400 milliliters. So as you would know, that's 350 milliliters. Here, we're past 500 milliliters. 500 milliliters is half a liter. So, but we're past that. Let's see what they're counting by in this one. So if this is 500, that would be 600, 700, 800, 900, 1,000 milliliters or 1 liter. So remember that 1 liter is 1,000 milliliters. So on this container, remember again, we're going to look at this front line here that shows that we're right there at 600 milliliters. It's always good to check and see what increments are being counted by on here. This one's doing the same thing. So we're at 1, 2. You see that line right there? So we're at 200 milliliters. So let's review quickly. It takes 1,000 milliliters to equal 1 liter, or that big water bottle. Let's practice some more. Here, where they're showing us this container here, and they're asking you, hey, if this container was filled with liquid, and then we poured it out into these measuring containers, how much liquid, or what was the capacity? How much could it hold? So capacity is what it can hold. So the capacity of that pot, so look at here, we have a full liter, a second full liter, and part of a liter. So we can say it in milliliters. Down here for our answer, it says the capacity of the pot is this number of liters and this number of milliliters. So we're going to have to split it. It's kind of like saying, like pairs. Not pairs, but it's like saying you have 2 wholes and a partial, but we get to use this smaller unit. So for the capacity of this pot, we would say there are 2 liters, 500 milliliters. I know last week on some of the kilogram and gram work, a lot of you wanted to say, maybe for this you would say 2.5 liters, which is accurate, but this is much more specific. And so this is helpful to give actual numbers to that instead of saying a half. So saying that that's 500 milliliters. Let's practice a couple more. Here we're going to be converting. The reminder on this page is really important right here. So this student is thinking and reminding himself that 1 liter is the same thing or equivalent to 1,000 milliliters. So if I have 3 liters, it's like saying I have 3,000. So when I go to convert that, I can go, oh, I just need to know how many milliliters I have. So I have 3,000 because there were 3 liters and 250 milliliters. So that's going to be 3,250 milliliters. You can think of this as a number bond. If I have 3 liters, a liter, a liter, a liter, all of those are also the same as 1,000 milliliters. I'm going to write right over his face, like that. Okay, so as we go on, if I have 4 liters, remember again, that's like 4,000, and then I have 600 milliliters. So if I go back to this pen, we will have 4,600 milliliters, always including the unit, so you remember what unit you're working with and what you're talking about. 2 liters is like 2,000 milliliters, and it has 80 milliliters. Be really careful because you don't have any hundreds in this one, so 0 hundreds, 80. So 2,080 milliliters. It's the same thing, it's equivalent. 6 liters, 70 milliliters. Be careful again, you don't have hundreds for this one. So 6,070 milliliters total. This time we're going to be taking our milliliters and converting them out to liters, milliliters. So whatever's not in the thousands, this leftover has to stay with milliliters. So watch that. That means we're going to have 90 milliliters. And I have 4,000, so that's 4 liters. Look at this one. This one's kind of fun. 6,000 milliliters. You don't need to put anything in the milliliters because there's nothing left over. So the correct response for this one would just be to say 6 liters. You don't need to put anything in the milliliters. Okay, on the third one, we have 5,008 milliliters. So you're right that the 8 milliliters just sits over there, and 5,000 milliliters gets converted to 5 liters. Okay, we're going to look at a story problem with capacity. So we're talking about a fish tank in this problem. A fish tank contains some number milliliters of water. The tank's capacity is a number of liters with a number of milliliters also. How much water is needed to fill the tank completely? Give your answer in liters and milliliters. So just like at school, we're going to practice by rereading this problem again. Let's look for some key information that will help us think about this. So the fish tank contains a number of milliliters of water. So that's kind of what I envision. I just see a fish tank like, ooh, I feel like I should do a different color. I see a fish tank that's partially filled. And there's a number of milliliters in this part. Okay. The tank's capacity, so remember when we see that word capacity, that means how much it can hold if it was filled to where it's supposed to be filled to. So that capacity mark to me means maybe that we need to get up to like here. So this is what we already have, and this is what we don't have in there yet. How much water is needed to fill the tank completely? So can you imagine you put some water in this fish tank, but you want to fill it up completely, and you need to know how much more water you need to fill it up completely. Another key thing I'm noticing here is that it says to give our answer in liters and milliliters. Doesn't that make you want to write out your answer right now so that you remember what you're solving for? So your answer might be, we go back and we look here, to fill the tank completely. To fill completely, you need some number of liters and some number of milliliters. We're going to be as specific as we can. So if we look at this bar model, this is the number of milliliters that's already in. This longer bar is representing how much the tank can hold, so the capacity. So we know what's in the tank already. We also will know what the capacity is. What we don't know and what we're going to have to find out is how much more do we need. I'm going to label that with an X. You can label it with a question mark. How much more do we need to fill the tank? So let's reveal some information. The trick with this is that you see here that we're going to have the number of milliliters, but it tells us the capacity in liters and milliliters. So we're going to have to do some converting, just like we practiced on the previous pages. All right, so here we go. The fish tank contains 4,130 milliliters of water. So remember, this is what's already in the tank. And I'm going to keep that label there to remind myself those are milliliters. The tank's capacity is 9 liters, 550 milliliters. Let's convert that just to milliliters. So, I don't know if I said that correctly, 9 liters, 550 milliliters. So that would be 9,550 milliliters. And that's how much the whole tank can hold. Now I'm working in the same unit. Both are milliliters. So this is 9,550 milliliters. And remember, this is what we're trying to solve for. Do you see that we will be doing 9,550 minus 4,130 to find what x is? Let's also remind ourselves what we're solving for. my sentence might look a little different than the last page. We need blank liters and blank, don't forget we need liters and milliliters in our answer to fill the tank. Okay, so we need to subtract. I feel like I'm running out of space here, so I'm gonna try and write this kind of small. You know that you guys have so many different strategies for subtracting. I'm gonna just show you what came first to my mind, is that I can keep my 9,550 and I'm gonna subtract out 4,000 first. That will leave me with 5,550 milliliters. From that 5,000, so now I've used the 4,000. I kind of want to use the 30 next. I'm going to write it over here, minus 30. That will give me 5,000. The hundreds are not going to change, but 50 minus 30 is 20, so 5,520. And now I need to use the 100. So minus 100 will give us 5,000, oops. We will be at 5,000, taking out 100, so that's going to change our hundreds. 420. This is milliliters. So, phew, I feel like I'm done. But as you can see, we're not done quite yet because we need to now convert this to liters and milliliters. Remember, every time you have 1,000 milliliters, you get a liter. There's 5 of the 1,000, so that would be 5 liters. And then this leftover that doesn't make 1,000, that's the number of milliliters. So we will need 5 liters, 420 milliliters to completely finish filling that tank. Okay, that's our work for Monday. What I'd like you to do is, if you can, do the practice work in your math workbook first, because that gives you a chance to practice these skills. So the work is on pages 35 through 38. That is workbook B. Also, flip to page 42 and complete problem 4. You did problems 1, 2, and 3 in that section last week. Go ahead and review those with somebody at home. Make sure they're making sense to you. On Seesaw, you will find a milliliter and liter practice. But if you do the workbook pages first, it'll be easier for you to do the practice that's on Seesaw. Also, I'm going to put an exit ticket up on Seesaw. So that's it for Monday. Pause here and come back to this video for Tuesday's practice. Welcome back. It's Tuesday, May 12th. We're going to talk about more units of capacity, but today we're going to talk about the U.S. customary units, so not metric. Here you will see a very confusing chart. Again, we're back to our U.S. customary units, and the conversions are not as easy. I am going to show you that I have a couple things in front of me. This is a 1 cup measuring cup. I bet some of you have seen those in your homes too. So up to this line is 1 cup. 1 cup is also the same as 8 ounces. You will probably notice on your measuring cups at home, like this one, is that the other side actually has metric. So there's some similar comparisons. You can see that up to this point on this measuring cup, that line is about 250 milliliters. So we're not even at half a liter yet. So this is 1 cup. This slightly larger measuring cup here in this hand actually gets me up to 2 cups. And 2 cups is 16 ounces. It's also half of a quart. You may have heard of a quart before. And so that is also kind of handy because sometimes I'm measuring something and I need a little bit more, or I don't want to have to count out as many cups. I can do it more efficiently this way. I actually also have one that's for 4 cups. You see the difference? So this is the 2 cup. This is 4 cups. This is back to that 1 cup. You might go scavenger hunt in your kitchen a little bit. So up to here is 4 cups or 32 ounces. 4 cups is the same thing as 1 quart. Remember, we talk about things not being accidental. So do you notice that I said 4 cups made a quart? Remember how we've talked about quarters of a football game or quarters that make $1? There's 4 quarters that make $1. There's 4 quarters in a football game. So that quart, it's not an accident. And actually, it takes 4 quarts, so 4 of these 4-cup measurements, to make a gallon. I don't have a gallon jug of juice or milk in my fridge right now. I have a half gallon. Anyway, so it takes 4 of those. So that should make that a little bit easier to think about. So if you see on this chart, we have so many things going on. We have the ounce. An ounce is about 1/8 of a cup. And the reason I say that is because it takes 8 ounces to make a cup. So you can say that 1 ounce is 1/8 of it. So if I have 1 cup, I would have 8 ounces of liquid. I would have half a pint. I didn't even talk about those yet. A pint is 2 cups, which we'll get to in the next one here too. And these are really not important, but I just want you to know that because, for example, there are 16 cups in a whole gallon, that would mean that 1 cup would be 1/16 of a gallon. That's why I put this one here. So a pint we kind of skipped over, but a pint is 16 ounces. It's also the same as 2 cups. So that was this medium-sized measuring cup, this one here. So here's the 2 cups. Here it says 16 ounces. It says half of a quart, which I have here too, half of a quart, but it's the same thing as 2 cups. All right, so then we go to a quart. Again, a quart has 4 cups in it. A quart is 1/4 of a gallon because it takes 4 of them to make the gallon. So look at how many ounces are in a gallon. That wouldn't be a very efficient way of saying a gallon. So we go ahead and we use 1 gallon. The equivalency to a gallon is 4 quarts, and then you kind of work your way back down this way. This is all really hard to remember. A couple of years ago, I found a couple other tools to help me remember these more efficiently. Here's a visual aid that I think is helpful too. So here we can see that we have 2 cups, and that makes a pint. 2 pints, so remember that in each of these pints is 2 cups. I'm going to put 2 C's in each cup. So is a quart. So a quart is also equivalent to 4 cups. Then we take these quarts and they go down here. Remember, quart, like quarter, it takes 4 of them. So there is, remember, there's 2 pints in each of these. I'm going to put 2P to signify those 2 pints in this 1 gallon. So 4 quarts to make a gallon. Or we can see that there would be 8 pints to make a gallon. And remember that each pint has 2 cups in it. So we take that 8 times 2, so it would be 16 cups to make a gallon. It's quite a bit. This is another fun visual that a lot of students have possibly seen. I think I found one that I can put on Seesaw for you to try out too. This is called the Gallon Bot, so a gallon robot. You can see here that our Gallon Bot's body is the gallon, and that there are the 4 quarts. So we're starting big and then getting smaller, basically, if we start in the center. So we have a quart, and we need 4 of those, and a quart, and a quart. So the beginnings of the 2 arms and the 2 legs, so those are our quarts. Remember, into each quart goes 2 pints. So then we go to get to pints. So we see we have a pint, 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 and a pint. Wow. 2, 4, 6, 8 pints. Then to make a pint, we actually get cups. So here we go with our cups. 1, 2, 3, 4 cups for each equivalent to the 2 pints, because it's 2 cups for 1 pint and another 2 cups for the other pint. Look at that. So he's kind of cute, and you could probably color him in too. I'm not going to do that. This was one of the first diagrams I saw about, I don't know, lots of years ago. But this one really helped me. It felt like a really efficient way to draw out what's happening. And I honestly, to this day, still visualize this, sometimes even draw it on a piece of scratch paper to remind myself how many cups it takes to make pints and quarts and gallons. Do you see how easy that is? Like if we follow along and just this giant G, this is signifying a gallon. Inside the gallon, it takes 4 quarts. So there's these 4 Q's. Inside each quart are 2 pints for each one. It repeats. Then you'll see, do you see the tiny, 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 tiny C's inside there? I don't know if you can see those. Here, I'll highlight them. So there's 2 little C's inside each one of the pints to represent the 2 cups. This one has really helped me and I feel like it's efficient. I don't think I would draw the gallon bot as easily. So I'm going to show you how I would quickly draw this on the next slide. So here's how I might take out a piece of scratch paper to remind myself about these US customary units for volume and capacity. So I would start by drawing a giant G, remembering that that G is representing the gallon. Inside that gallon, I can remember that I need 4 quarts. 1, 2, 3, 4. And quarts is easy for me to remember because I always go back to that idea of a football game or quarters and a dollar. So I need 4 of them to make the giant gallon. Then I know from there, each quart, I'm going to fit 2 pints in. I'll give you a hint. You need to make the inside of the P kind of big so you can fit the cups in later. See how that fills that up? And then inside each one of those pints, I need to fit 2 cups. Oh, those might not look like C's to you, but I know that there's 2 in each. So from here, when I'm working on my conversions, I can visualize this. I can draw this on a piece of scratch paper to my side and go ahead and get my work done on conversions with US customary units, or when I'm cooking or baking something. Okay, you're going to have a chance to practice work with conversion of those units that we just worked on. I just keep wanting to get some practice in with problem solving. So you know how I like to present them without the numbers first, and then we'll go ahead and add the data in. So when you're working on problem solving, feel free to cover up those numbers or ignore that they're there. When you read it, just say to yourself some number, something like that. So here for this problem, Glenn runs a number of times around a jogging track. Can you picture a track? It helps myself to visualize that. Jamal runs a number of times around the same track. Okay, so they're running at the same place. Glenn runs a distance of a number of meters. How far does Jamal run? So Glenn runs a number of times around a jogging track. Jamal runs some number of times around the same track. Glenn runs a distance of some number of meters. How far does Jamal run? Not quite sure we have enough information. So let's go ahead to the next slide and get some more information and start labeling our bar model. I do know, though, before we move on, that I need to find out how far Jamal runs. So for that, I might write my answer. Jamal runs. Oh, let's think too about what unit we're working in. Did you find it? Yeah, we're working in meters. So let's put that in our answer, blank meters. Jamal runs blank meters. I'm going to add that to our next slide too. There it is. I'm going to write it right down here. Jamal runs blank meters. That's what I'm solving for. That should help me stay focused. Okay, Glenn runs 4 times around a jogging track. Jamal runs 3 times around the same track. Glenn runs a distance of 992 meters. How far does Jamal run? Okay, so what I did with the bars here is, do you see that in this top blue bar, there are 1, 2, 3, 4 sections? So that can be for Glenn. And this second bar has 1, 2, 3 sections, and that can be for Jamal. So I'll go ahead and label this first one with a G and this one with a J. So they're running around the same track. So we know that if Jamal's run around once and Glenn's run once, they've run the same amount. If they both run twice, they've run the same amount. If they both ran 3 times, it would be the same amount. But do you see how Glenn went a little bit further? So here's what we know. Glenn runs 992 meters. Jamal runs less because he went 3 times around. So this amount is 992 meters. So do you see that I could partition, or I can share out that 992 and figure out how much is in each one of these sections. So you're right, it is like thinking about this as dividing. 992 divided by 4 equals what we're solving. Well, it doesn't actually equal what we're solving for. It equals for what each one of these sections is, right? Then I would have to do that, because each one of these will be that y, and then I'll have to do that 3 times. So there's a couple of different steps we're going to need to do here. Now, do I expect you to divide 992 by 4? Yes, I do. But do you have to do it with a standard algorithm? No. Does anybody see anything here that they want to do first? For example, if I'm going to make 4 parts, I know that I could do 200 4 times. Oops, not 2,000. How much of that 992 meters have I used so far? You're right, I've used 800. So I have 192 left. Do you see something you could do with, well, I was thinking we could do 50, but if I did 50, 50, 50, 50, and 50, that would be 200. I would have used too much. So maybe you want to try 40, 40, 40, 40. So 40, 40, 40, 40. So that is a total of 40 and 40 is 80. Another 40 and 40 is 80. So that's 160 that we've used, plus this 800. So far, we've used that. So now you can see that you have used 960. We have 30, so we didn't use that. We used 160 more. We have 32 meters. I bet you see it now. You know what 32 shared by 4 is. That's 8. So we're going to go ahead. I think for space-wise, I might turn these all into 8s. Are you okay with that? So I used 32 more, so I've used 192 over here now, plus the 800 over here. So we've used all 992. That means our y equals 248. So because we divided 992 by 4, we know that each one of these sections of the track is 248 meters. So that means Jamal did that 3 times. 248, 248, and 248. So we can add those 3 up. Some of you are probably already doing this in your head, and you're doing the 3 200s, which gets you to 600. The 3 40s, 40 plus 40 is 80, plus another 40 is 120. 8 3 times is 24. So now you might see that you have 744. So we know that Jamal ran 744 meters. All right, everybody, here's some practice work for you to do around some of the things we just did. So in your math workbook B, please work on pages 127 through 129. Check in with somebody at home to make sure you're understanding things. I found a gallon bot that I can put up on Seesaw for you to assemble yourself. So that will be there. It's Tuesday, so I'm going to post some more math tiles. 5 pages will be up there for you to work on. Remember, there's a button that you can save your work, any of your work on Seesaw, as a draft before you click the check mark to submit it. That way that you won't lose any of your work, and if you need more time to come back to it and do it at another time, that's completely understandable, and you just save it as a draft. Okay, enjoy the work. All right, for Wednesday, May 13th, we're going to work through problem solving, a couple of problems. We're going to use bar modeling as a strategy. We're going to make sure we state our answer in a complete sentence, and we are going to, most of the problems are going to have multiple steps that you need to do because you're in 3rd grade and you need to be able to do multiple steps. So let's practice. Here's the first problem we're going to look at. The mass of a cow is a number of kilograms. The cow is 4 times as heavy as a pig. So it's almost like it would take 4 pigs to make the same mass of the cow. Does that make sense? What is their total mass? So there's a few things happening that we're going to have to work on here. So we want to know the total mass of both the cow and pig together. So we're going to have to add those amounts together. We know that the cow is bigger than the pig, and it's 4 times as big. And we can show that using a bar model that has 4 sections. That means that the pig would be the same amount as just one of those sections of the cow, because the cow is 4 times. This is language you'll frequently see in math problems. And when you draw it out, it becomes much more clear. So we'll have a second bar that will just be one of those 4 sections to represent the pig. So in this way, we can say this top bar is for the cow, this bottom bar is for the pig. What we really want to know, though, in the end, is the total. The total mass. And we're working in kilograms. That'll be important for us to remember, too. So we're going to find that total mass in kilograms. So maybe we can label that with an X right now. When the information is revealed, we're going to know the mass of the cow. That we will know. We're going to have to find the mass of the pig. That we're not sure of yet. When we find the mass of the pig, we'll be able to take the pig plus the pig's mass plus the cow's mass, and that will give us our total. Okay, so let's go ahead and move forward and find out some more information. So here is the sentence that we're going to be solving for down here. The total mass of the cow and the pig is some number of kilograms. So that's important on this too. So we can see, as information's been revealed, is that the mass of the cow is 540 kilograms. So this entire bar, which is the cow, is 540 kilograms. I'm going to label the unit. That's important. The mass of the pig we're unsure of right now. And the total mass is what we're looking for. So this is what we're solving for. That's in the statement down here too. Remember how important it is to clearly state our answers. So we will be searching for this total. So remember how we put a bracket over here to say when we combine those 2 bars, that will be the total mass. So there are a couple steps here. So let's see if we can get one of the steps taken care of on this page. The first step would be, I need to figure out what just one of these sections are, right? So if the whole thing is 540, that's equal, I can share 544 ways to figure out what one of the sections would be worth. So I'm going to think about 540, and I'm going to start taking it apart into 4 parts. Now, again, this is a division problem, but it doesn't mean you have to set it up that way. I'm going to think about 540. Oh, and this will tell us what y is. So I'm going to think of 540, and I'm just going to go with easy numbers first. I know that I can take out 100 4 times. It's hard to write that small there. Okay, and now I've used, so I'm going to put my 540 up here also to remind myself what I've used. I've used 400. I can see I have 140 left to use. Well, the 100, I can use 25. 25, 25, remember that quarter idea, and 25. 2 25s is 50, the other 2 25s are 50, so now I've used another 100. Do you see that you just have 40 left, and 40 can be shared between these 4 groups as a 10. 10, 10, 10, 10. So that means each one of those sections is worth, you have to combine all of those together, so it would be 135. So we know that y equals 135 kilograms. Let's put that unit in. 135 kilograms. Can we remember that to the next slide? Okay, here are the bars again. So we solved for the pig. The pig was 135 35 kilograms. The cow's mass was 540 kilograms. Now, the next stage or step is that we need to solve for x. Do you see that we will need, because down here again, we're solving for the total mass of the cow and the pig together, so we need to combine those amounts together. So I have 500, so we're going to do 540 plus 135, and that will help us to find x, or our missing value. So you know that I like to break these apart, so I'm going to do 540 plus 100, which gets me to 640. 640, so I've used that 100, plus 35. I can do that one step like that. So 640 plus 35 is going to give me 675 kilograms. So I'm going to go back and kind of quickly check over my work. I added the 100, then I added 35, so I added the 135 kilograms. 540 plus 100 was 640, 640 plus 35, so just 40 plus 35 is 75, so 675. Checking my work, filling in the answer in a complete sentence. The total mass of the cow and the pig is 675 kilograms. All right, here's the next problem that we're going to walk through. This problem says the total capacity of jugs A and B is blank liters with a number of milliliters also. Jug A holds blank milliliters more water than jug B. What is the capacity of jug B? A couple things here. Capacity is showing up again twice. Remember, that's the amount a container can hold. So that's when we were talking about the big water bottle. I had a red one. It holds a liter. And we looked at how small those milliliters are. So the total capacity of, can you picture two water bottles of different sizes next to each other? So one jug A and B together are holding a number of liters, milliliters. Jug A is bigger because it holds a number of milliliters more than jug B. And we have to figure out what the capacity of jug B is. So when I'm looking at this problem, I know that A is more and B holds a little bit less. The other thing I'm seeing is that it's asking us to give our answer in milliliters, although up here I have part of my information in liters. I'm going to have to convert that number of liters into milliliters. That way, and then I can work with this data here, the number of milliliters more that jug A has, and then I will be ready to give my answer in milliliters at the end too. So we know a couple things more. We know the total amount that A and B are holding together. So we're going to know this information. We also will know the amount more that A can hold than B. That information will also be in our problem. To figure out, in the end, what we want to know is this capacity of B. How much can be in that jug? So that's maybe the X that we're looking for in our answer. But in order to find that out, we're also going to have to figure out what is in A. So you see how we have multiple steps. Maybe we'll consider that our Y piece of information. And our answer is going to be the capacity, so how much it can hold, of jug B is blank. What unit do we need? Milliliters. Remember, the abbreviation for milliliters is lowercase m and a capital L. All right, let's look at the next page. Okay, we have some more information. The total capacity of A and B together is 5 liters, 330 milliliters. Jug A holds 850 milliliters more than jug B. What is the capacity of jug B? We're going to give our answer in milliliters. Let's label our bar model. So this is A and this is B. The total capacity of both of them together is 5 liters, 330 milliliters. When you see 5 liters, you should also be thinking that its equivalent is 5,000 milliliters. So putting that together, we have 5,330 milliliters in both jugs together. We want to find out what the capacity of B is. We don't have that information. We do know that A is bigger than B and it holds 850 milliliters more. You can also remind yourself that that's like saying this part of this bar is 850 milliliters. So can you see that if we subtract 850 from the total amount, then it's like getting rid of this portion, and then we get to divide that amount by 2, because that will be what's in each of these sections, because this part of B to this part of A are exactly the same amount if we remove the 850. So let's go ahead, and I'm going to flip to the next slide so I have a little more space to work. Okay, so this is 5,330 milliliters. This section is 850. This is what we're looking for. I'll remind you of that. This is A, this is B. And we talked about how we need to subtract out 850 from this 530. I kind of started looking at that subtraction problem and thought, oh, I'd rather count up. So I'm going to go 850. How much do I need to add on to that to get to 5,330? Well, let's get to 1,000 first. So if I add 100, I'm going to add 150. That gets me to 1,000. 50 gets me to 900, and then another 100 gets me to 1,000. So can you see how quickly from here? So we've added on a 50, so we're finding that distance. Now I know that I need to add 4,330, and that will get me to this. So we just found the distance between those two numbers, or difference, the subtract, how far apart they are. So put those two together. Now you have found that those together is 4,480. So that means that between bar A and B, the parts that are the same length, these sections right here, is 4,480. So I need to divide that by 2 to find out what just that one section is. You can see, because we took out the 850, that we can share this number of milliliters by 2. So again, you might see here that it might look even more friendly just to go, oh gosh, I can split 44 in twice by saying 2,200. Do you see that? And then I just have this 80 left to split, so that's going to be 40. So I can see that when I divide 4,480 by 2, I would get 2,240. So that would be the amount of the bar from here to here and here to here. Each one of those would have 2,240. Oh, maybe I need to change to the right. 2,240. Then if this is 850, if you put those three parts back together, you're going to get back to this amount, the 5,530. So we know that jug B holds 2,240, and we were working in milliliters, so we can record that here. 2,000, oops, need a different color. 2,240 milliliters. All right. For Wednesday's practice, you have a few different things. In your workbook B, please work on pages 45 and 46. There will be 4 story problems. Remember to use strategies of bar models, check your work, or record the units you're working in, and state your answer in a sentence. Okay, and then, review with somebody at home. On Seesaw, I'm going to post a kind of fun conversion worksheet, so you're converting capacity units of measurement, like the pints, quarts, and gallons. With the idea that you're making lemonade for a group of people and you need to think about how much you will use. I would suggest you do your work and thinking on some scratch paper, then you can just record your thinking on the Seesaw template. The math tiles are still there for you to work on. You can also go back and finish math tiles from previous weeks because those are still there too. All right, have a great Wednesday. Pause here. and come back for Thursday's practice with clocks. Hi, welcome back. It's Thursday, May 14th, and today you will be working on clocks. So I know that some of you have practiced this quite a bit and some of you feel like you need some more practice. So either way, it's a good thing to practice. So we're going to tell time to the nearest minute. That's what's expected of you as a third grader. And you remember that when you look at a clock, that every time when we're thinking of minutes, every time you see a number, you can think of that as one group of 5 minutes. If we're down here, this is 4 groups of 5 minutes, which would be 20 minutes. This shorter hand is the hour hand. I'm going to write an H over it. The longer hand, I've taught some of you before to say, think about a minute. The word minute needs a longer line to sit on, so that's why it's a longer line. That's the only way I remember it. There's different words that you'll hear people use when they're telling time, and sometimes it's frustrating until you become familiar with it. So a lot of times we'll use words like minutes past an hour. So how far into the hour you've got. So if you said that we are 12 minutes past 2, that means it was 2 o'clock, but we're 12 minutes past 2 o'clock. So it would mean that it's 2:12. We can also say minutes to an hour. We might hear somebody say 20 minutes to 4 or 20 to 4. And so what that would mean is that there are 20 minutes until or to 4 o'clock exactly. So it's not 4 yet, it's about 3:40. Other words that you'll hear people use when talking about time or telling time is they'll say quarter after, they might say quarter to, they say half past or half to. Other words as noon and midnight, which we've talked about all of these. Remember that you can think of the clock face in a circle. If you cut it in quarters, that you would see what the quarter hour is. Quarter after would be 15 minutes, because that's quarter of the way through the hour. If you add 15 up 4 times, you would get 60 minutes for the full hour. Quarter to the hour is when we're at 40, or quarter to the next hour, I should say. You're at 45 minutes into an hour, and you only have quarter of the 60 minutes left to get to the next hour. And half past would be 30 minutes. All right, here's a couple clocks. We have both the analog clock, which are these, and we have a digital clock, which are these. And we're going to talk about the minutes past an hour. So for this one, you see our hour hand is at 5, or slightly past 5. Our minute hand is at 2 groups of 5 minutes, so we would have 10 minutes. So we would say we are 10 minutes, you can abbreviate minutes with an MIN, past 5. That's not so bad. For this one, you could do a couple things. You could say 32 minutes. This isn't very commonly said, but they just want you to practice. 32 minutes past 2. Down here, here's our hour hand. Notice how it's past the 6, but not to the 7 yet. So it's still 6 o'clock. We have 5 groups of 5 minutes, so that's 25 minutes. It might help me to write it over here first. So again, we can say 25 minutes past, what was our hour again? 6. 9:39, we would say 39 minutes past 9. That's just a way we can say it. All right. Here we have 3 hours is how many minutes? Well, first of all, we need to remind ourselves how many minutes are there in an hour. Every time these are these conversions. 1 hour, well, maybe I don't need to say hours. One hour is 60 minutes. It might help you to kind of go ahead and count up by 60s. So if we were counting up by 6, we would go 6, 12, 18, 24. So that's 6 groups of 10, 12 groups of 10, 18 groups of 10, 24 groups of 10. Do you see how this is going? 30 groups of 10. It keeps going, and I ran out of space. So here we can look at 3 hours. So that's 60. That's 3 groups of 60. Here it is here, 180 minutes. 180 minutes. Let's do this one. We have hours and minutes that we're going to, 2 hours would be 120 minutes plus 29. So together, that's going to be 149 minutes. I'm going to skip around a little bit so we can get through this. Now we have where we're going to take the number of minutes and we're going to break that into hours and minutes. 270 minutes. I'm going to go back to where I was counting up by 60. So 60, 120, 180, 240, 300. So 270 is between 240 minutes and 300 minutes. So 240 minutes would be 1, 2, 3, 4 hours. And I got to 240, there would be 30 more minutes. So it's basically 4.5 hours. Did you see that? Let's look at this one, 305 minutes. Oh, look at that. So that was that 5-hour mark. 5 hours, 5 minutes. All right, over here on this page, it's going to be a little simpler. We're just going to do this one down here because of space. 420 minutes. Oh, we didn't count up that high, but I do remember that if I just think of 42, how many 6s are in 42? So 42, so I'm thinking of 420, so 42 groups of 10 shared by 60. But remember, you can kind of think of it like this. 42 shared by 6, 7. So that would be 7 hours. It might help you to write some notes of counting up by 60 and just keep going. For your practice for Thursday and clocks, go ahead and work in Workbook B, pages 143 through 146. Practice telling time with past and to, a couple of different ways. Review those with somebody at home. On Seesaw, there's going to be a telling time worksheet that I found, so I'm going to post that up there. Go ahead and tell time to the nearest minute. Math tiles are there for you to continue working on. Pause here and come back for Friday. All right, we've made it to Friday, everybody. It's May 15th. Today is going to be another kind of catch-up day like we did last week, just to give you a chance to go back and catch up with any of your math stuff, practice your math facts or multiplication facts, or things on Seesaw, or any other thing that you kind of need some time to get caught up on. So here's some things that you can go back to review. The assignments that you got this week for Workbook B are listed here. So this week's pages, and you can go back and make sure they're finished, that they're complete. Maybe there was one you had a question on and you wanted to go back with fresh eyes. So you have pages 35 through 38. Page 42, it was only problem number 4. Page 127 to 129. Page 45 to 46. And pages 143 to 146. On Seesaw, I'm going to post one new problem. I'd like to see how you're doing on your problem solving with bar modeling and things. So I would suggest you do the work on scratch paper first so you can really kind of figure out what you need to do to complete that problem and be able to show your work. If it's too hard to draw bars and things on Seesaw, I get it. Take a picture of your work you did on scratch paper and post it up. The other thing you can do on Seesaw is go back and complete any previous work from this week or previous weeks. Math tiles. Those are still on Seesaw, and you know what to do with those. All right, it's been a great work week. We've got a lot done. We've talked about milliliters and liters. We've talked about gallons. You looked at a gallon bot. You did some conversions of units with a Lemonade Mania. You have also been working on some problem solving, 2 steps or multiple steps, and working with bar models and stating those answers clearly. You did a great job. I will see you next week.